We are starting the revision for this chapter, gravitation and circular motion. Okay, so we are putting the first concept. Let us now observe the first concept. Examples. First, we are discussing the important concepts of circular motion. Okay, I will be asking some questions also. This is a combined chapter, gravitation and circular motion. So what is the first concept about circular motion? In a circular motion, the most important feature which comes first is the time period. Time period has a formula 2 pi upon omega. What is time period? What is time period? So when something is moving in a circle, this is the diagram, and the velocity is like this. The linear velocity is tangent at a point, and this is what? This is omega. What is omega? Omega is the angular velocity. And what's the formula for omega? Theta upon t. And the formula for velocity and omega v is equal to omega r. Circular motion is a periodic motion in which there is a constant radius. Circular motion is a periodic motion in which the object is moving at a constant speed and a constant radius. Now you have to remember this idea that circular motion is a periodic motion. What's a periodic motion? Which repeats itself at regular intervals of time. What is theta? Theta is angular. Theta is angular displacement. So if this is the circle and an object is moving from position A to position B, this is the theta. What is theta? And the formula says S is equal to R theta, and theta is equal to S upon. Acha, what's the unit of theta? Radian. There comes the most important definition of this chapter. What is radian? The radian is the angle subtended at the center of a circle when arc length is equal to radius. Now you can also write with me the way I'm writing. Take a loose page and just like, not a fixed notes, but take any one loose page and do some writing with me. This will be a type of organic revision. And whenever ask a question, you people can answer me. This is a rough type of way that when you write, you are able to revise. Now we have revised 2 to 3 important concepts. In every circular motion, the resultant force is always directed. The resultant force is always directed towards the center. The resultant force is always directed from towards the center. And what's the formula for resultant force? Resultant force mr omega square. In a circular motion, the acceleration is also directed towards the center, and acceleration is equal to omega square r, and acceleration is equal to v square upon r. Now look, the way I'm scribbling, you can also scribble. You can write some things, avoid something, write something, overall look at something. Revision actually means you have to flash back. You have to see that how much you can recall. Now the next concept, which is the core concept of this chapter, what is the centripetal force? What is the concept of centripetal force? Sir, it is caused by gravitation. But it's not always caused by gravitation. Like a motorcyclist, like a bicyclist, so it can turn anytime. Now, what is the concept? Circular motion is a forced motion. Nothing wants to go in a circle happily. So circular motion is a forced motion. In order to keep an object in a circular motion, the resultant force should always be directed towards the center. And this force, the resultant force, which is directed towards the center, this force is called as centripetal force. Centripetal force is the core concept. Now, what is the most difficult concept of this chapter? This chapter is very friendly, doesn't make any big problem. Normally, it comes with subtopic of gravitation. Now, there is only one concept of this chapter which can give you a trouble. This is linear velocity and this is resultant force. Now, notice that are they perpendicular to each other? Now, this perpendicular relation is responsible to create the angular velocity. I repeat the concept. Centripetal force and velocity are always perpendicular to each other. This perpendicular nature creates the circular motion. In every chapter, there is a core concept, there is a core derivation. In A2, this happens like a memory lane. And there is one or two concepts which are always challenging. Lucky point is that everything is in your recall. This is fine. Graphs are really challenging. There are two to three chapters, which really challenges in graphs. Electric field, which is we did some time back, I think, and gravitation graphs are really difficult. So I repeat the concept. In a circular motion, how a circular motion is created? Resultant force is always perpendicular to linear velocity. That linear velocity and force perpendicular nature creates circular motion. Good. So we are done with circular motion revision. And I told you that we are doing a quick revision. The main idea is to do some revision today. And then they say he has some question. Anyone can ask any query, conceptual query. Question query, you people can send me WhatsApp, or if we get time at the end of the class. Now I start gravitation. It's a heavyweight chapter, comes every year. It is the first question of the paper 4. Gravitation, the first concept. Why gravitation is a universal phenomena? Hmm? When two masses come into contact, they feel a force of attraction and gravity. Good. Why? Every mass, you have answered your partner. Now, Ahmed, why gravity produces attraction? No, your face means you're happy. Okay. Here, he has already given this idea that gravitation is a phenomena of attraction. Why? My question was why this concept is universal? Because it stretches throughout the universe. Every mass creates a force field around it. Every mass creates a, and is this field I'm drawing, is it a radial field? And the field lines, these field lines are called flux. And what's the unit of flux? Weber. So now I'm starting with his concept. Gravity is a phenomena of attraction, and gravitation is actually due to what? Mass. My second concept, revision concept. Every mass creates a field. Every mass creates a field. And two masses, when they come together, these fields try to converge, and this, as a result, is there to produce attraction. First concept is complete. This is the main concept, but not a concept which comes every paper. Now, obviously, the chapter proceeds and chapter put the next concept. There are two types of masses. You should scribble with me like this. It's a memory way to run up in your organic brain. And this is the way to do some revision. Point mass and extended mass. Now, what's the difference between them? Other people should also answer. Sir, point mass sir symmetrical होता है. Same density. Yes. Point mass is. Sir, extended mass is non-symmetrical and the density of gravitational field is very throughout the object. Throughout the object. Okay, anyone else? What is a point mass? What is an extended mass? A point mass is symmetrical. An extended mass can take any shape. A point mass is symmetrical, while this mass can acquire any shape. Now, there are two types of masses. Now comes the core concept of this chapter. What's the core concept? Yes, Newton's law of gravitation. Newton's law says that force of attraction between two masses is directly proportional to the product of the masses and inversely proportional to, and when you combine them, it becomes gm1 m2 upon r square. What is the statement of Newton's law of gravitation?
The force of attraction between two isolated point masses is directly proportional to the product of their masses and inversely proportional to the square of this.
Could anyone from here? I'm not asking from Ahmed. He's still smiling. Answer, but remember this. The product of masses and inversely proportional to the square of the separation between the 2 point masses. Okay, that's a good definition. Now, Newton's law of gravitation is the core idea of gravitation. Now we move forward. Is it right that when masses are well separated, like we make a sun and we make a planet here, when the extended masses are well separated, do they behave like point masses? This is an assumption. What's an assumption? When point mass is given, it is directly applicable for valid for Newton's law. But for extended masses, they should be well separated. Acha, when they are well separated, an extended mass will behave like a Acha, he was emphasizing on a word isolated. Why the word isolated is important?
Isolated. Sir, वो क्योंकि उन दोनों में so that there is no other influence of gravity.
Yes, because we actually focus mass 1 and mass 2, no other mass. Isolated means other masses are not going to interfere. Good. Otherwise, we are not living in isolation. We are living in a network of gravity. Like when you open your mobile phone, check the Wi-Fi, you will find 2, 3, 4 networks. This is called system of network. But at a time, your mobile phone will be connected with one source only. So similarly, we have an assumption: one mass, one source, one test mass, one source mass. This is called isolated concept. Now, I move forward. I have discussed the idea of Newton's law of gravitation. I have discussed its formula. Now I move forward for two important derivations. The first is the idea that this is the source mass and another particle with small mass is orbiting it. Satellites, moon, planets, comets, meteors, all of them follow this. The orbit in our course, we assume the orbits in our course are circular. Okay. Now, this mass is orbiting a bigger mass. Why it is orbiting, and if it is orbiting, how this smaller mass is getting the centripetal force? Very good. Gravitational force is equal to centripetal. Gravitational force is equal to. Now there are two derivations here. Both of them are important. One of them is so important that this is appearing in countless times in the paper. Gravitational force. Should I write G M upon R square? Now look at the screen. On the right side, should I write centripetal force mv square upon r? R cancel, m cancel, then
V square is equal
gm upon r is equal to v square. What is v?
to
Now what is this formula?
satellite
This formula is called the calibrated velocity. It is called the launch velocity. Actually, it is the velocity at which an object can orbit in a satellite. Acha, if this velocity is not there, then the object will not orbit in the required satellite orbit. This is the velocity. So anything which wants to orbit and in an of anything which wants to orbit a position, it has to follow this formula. For example, our planet is orbiting the sun, provided it follows the particular value, it follows the particular velocity. So this formula is under root gm upon r. This derivation comes off and on, not very, very important. But now look at the second derivation for the same situation. What is the core idea? Which is the very important idea of this chapter. Gravitational force becomes. Why this derivation is coming again? What's the difference now? Gmm upon r square is equal to mr omega square. Cancel. Then gm upon r square is equal to r omega square. Can you now this is the most important derivation, and for memory is this derivation is the Kepler's. The name is not important. Now they're not going to give the name Kepler's third law, but this is only a reference. Now I will do what? How I'm going to proceed? Quick memory. R square go there. Will it become R cube? Okay, now
GM is equal to omega square r cube.
GM is equal to R cube. In place of omega, should I play time period? Acha, GM is equal to R cube 4 pi square upon T square. This is a scribble way of revising, and I'm writing it. Obviously, I have written, I don't know how many times you people also have written it, but organic memory always work in this way. You have to write, you have to read, you have to write. Writing is the best source. Now, how should I proceed? T square comes here, 4 pi square upon
R cube of
and T square is what?
constant.
And this statement is called Kepler's third law. The name is not important, but can we make a relative equation here? T1 upon T2 whole square is equal to R1 upon R2 whole cube. Now, this relation is called Kepler's third law, but the main thing which comes in the paper, if you people have done the questions, am I right if I say this is the main equation?
Yes.
This comes in the paper. You are supposed to make the derivation and then you are supposed to use it for your answer. I have done the most important derivation. I moved to one of their favorite definition, gravitational field. And nowadays, is he using the words strength?
Gravitational field.
And he's using only the word gravitational field. And they say, okay, you should remember gravitational field strength, the symbol. Definition. Gravitational field strength is the force per unit mass. Acha, what is the concept of gravitational field strength? Concept says it is the signal strength of gravity. Like Wi-Fi signal, any signal, it shows how much gravity is intensified at a particular position. Is G a vector? G is a vector. And for the surface of the earth, The value of G is 9.8, but it can change. It can always change. Now, what is the derivation? Now, we want the gravity to pull us. Here, we are not interested that gravity should give us a rotation. Here, we want gravity to provide us weight, pull. So, how I derive this? Here, I will say now gravitational force is equal to weight. This is a rare derivation. It doesn't come much. And if you have done past paper, you know that in A2, they have some real favorites and some dislikes, like some topics come every other time. So how should I start the derivation?
F is equals to GMM upon R.
Gmm upon R square, and here mg. Okay, good. Mm cancel. G is equal to Gm upon R square. This formula can be rearranged for a rare question also, that m is equal to G R square upon G. And what's the value of G? Minus 11. It's basically, it's a constant of universal gravitation. Now, I also want to remind the sketch here, that if I put G here and I put R here, will it be a curve like this?
Yes.
So what it means, that G and separation are a very common trap which comes in, which should be recalled, that which I explained in my normal class, that if I plot G against 1 upon R square, will it be a straight line? Why?
Yeah.
According to linear law. According to linear law. Now we move forward. We have revised gravitational field strength. Now comes another topic. This is a big chapter, long chapter, and we have a title here, gravitational. One of the most important definition here comes in. Please go on. Anyone can want to tell the definition of gravitational potential? Two people are telling. Anyone from here? Else? Anyone else? Please.
From infinity to the point.
To the point. Very good. So that's good. And what is the formula? Phi is equal to W upon. What is the second formula? Its derivation is not important, so I'm not going after it. Why there is a negative sign? Is it a very important question? Why gravitational potential is always negative? It's a scalar quantity, and when you're moving towards the center of the earth, the work done gradually decreases. So this symbol means that phi is always negative, and it's normally it's a 2-mark question. Why it's negative? Because gravitational field is attractive, and the work done in moving object gradually decreases. Good. Now we move to the idea. I'm not going for gravitational potential difference because that's a part of it. Now I comes to this terrifying symbol, gravitational potential energy. What is potential energy? Potential energy is a direct consequence of work done. Gravitational potential energy is the work done in a gravitational field due to the position of the object. So what is U? The first formula of U was mgh. But this is not workable for objects in space because G varies. And then the second formula is U is equal to minus Gmm upon R. Why U is negative? Because number one, gravitational field is. Second point is different. Number one is same. Because gravitational field is attractive. Second point, no object can escape from the field itself until it provides that much energy. So for example, your gravitational potential energy is minus 20. So it means it's like a cage, and you are in a cage at a cost of 20 rupees fine. You have to give this 20 joule energy. Then after this energy, you can escape. People always talk about escape as a word because escape means that you can go out of gravity of that particular field. Now this is the universal gravitation concepts. We have covered the whole revision, and need a volunteer to divide the papers here for doing one question. Meanwhile, anyone has a question, they can ask. Ahmed, sitting. Hmm? But the same problem, na, we have to go for everyone. Na? Jaldi divide karo. Now, this is basically a trial question to see. This is not a test, but we are working together, and the idea is to check how much we have learned. I have posted the formulas. I have made the revision videos. Everything is on the chat. Thank you. This is the paper June 25, paper 42. June 25, 42. Okay. I'm starting with question number 1. Their favorite definition. You people can write on this. You people can put your name on it and put it in your past paper books for record. Because you know, I think it's 41 perhaps.
41. Question 1.
June 25, paper 42. Okay, this is June 25, paper 42. This is June 25, paper 42. First question. The first question, define the radian. When arc length is equal to? Good. So first we put the definition. The threshold for this paper was 60 out of 100 for A grade. Now, what was the definition? Everyone should recall the important definition. The angle subtended at the center of a circle when the arc length is equal to the radius. And I have drawn a diagram to recall. Diagram is not needed. Why I'm doing this question? This question was a very much criticized and very much objected style question, that this is too much complicated. Until if you have a experience of using bicycle, the chain one, the regular bicycle, and you have a taste of running it regularly, and in your childhood, especially if you have an experience of managing the chain of the bicycle. So this question was difficult for many people. The rear wheel and the pedals of a bicycle are connected by a chain that passes around two cogs tooth wheel as shown. So this question, very long time back, this question is not on space, not on satellite. It's a real life question, but challenging because it involves bicycle. Now, if you people have run these regular bicycles, no any gear, nothing automation. Now, this is a manual bicycle, one small wheel with the two pedals, one big wheel at behind with a spike wheel with it, so it can turn with the chain. Now, observe the diagram carefully. Small cog radius 0.038, real wheel radius 0.46. There are two pedals, large cog radius 0.15. The people who are having a good understanding, why is one cog wheel is bigger and one is small? Because of the control of moment. In a bicycle, your power is less. So less power can move a bigger thing by using the concept of moment. Now, the small cog has a radius of this much fixed to the rear wheel so that it rotates with it. The large cog has a radius 0.15 meter and is fixed to the pedals so that it rotates with them. The rear wheel has a radius of 0.46 meter. The bicycle is being pedaled so that it moves in a straight line at a constant speed of 17. Calculate the angular speed of the rear wheel. What is angular speed? Does it mean omega?
Yes.
Angular speed means omega, and this is omega. Let us recall the two formulas of omega. Omega is equal to theta upon t. Second formula, omega is equal to 2 pi upon t, time period. There are two other formulas. I want to mention them also for my memory recall because we are in the revision mode. And then second is V is equal to, there are four formulas in total which can control omega. Now select a good formula. Okay, good. Now go for it.
सर इन दोनों रेडियस साइड हो जाएंगे
Huh. No, sorry, what do you mean? No, there is nothing addition. No addition, direct one answer. Ahmed, no copy. Good. The answer I am getting is 37. Now calculate the period of rotation of the small cog. So what's the formula for time period? 2 pi upon omega. If the two wheels are connected, if you people have driven bicycle, if the two wheels are connected and they're moving together, will they have the same omega?
Yes.
omega will be same because they are connected objects. I have used the formula t is equal to 2 pi upon omega, and then I put it here. For time saving, I'm showing the working. You people can do yourself and compare the answer. So that the distance moved by the point x on the chain during one complete rotation of the small cog is 0.24. Now let's look at this small. There is a small cog and there's a large cog. And identify this is point x. So what is asking here? Suppose it moves like this. It will move like this. Will it move like this? Then okay, we can use the time period. So once one revolution means he's talking about time period. And then is he talking about some type of circumference formula or something use that? Or angle, huh? We can go for it, but then you're talking about for one cycle, I should take 2 pi. That's also a good idea. Okay, now give me quick suggestion. So for one cycle, the distance is 2 pi r, and I can simply put the circumference formula, radius I will put, and I get the distance. How I make a connection here with circumference? Why circumference? Because it's one full rotation. So this is a suggested answer. If you people are getting this answer, let me update. Use the information in B part 3 to determine the angle through which the large cog rotates during one full rotation, should we apply the formula which she was recommending? S is equal to R theta here. Theta. And second formula, omega is equal to theta upon one formula for theta, S is equal to R theta. Second, which involve theta, is this one, which means theta is equal to omega t. Another formula which can calculate theta is 2 pi. Now, which suits me here, and it's necessary. S is equal to R theta will give me answer in radian. Good. Do the working quickly. Now, look at the last part, theory part. The chain of the bicycle in B is moved onto a smaller cog fixed to the rear wheel. The speed of the bicycle does not change. Explain without calculation the effect of the change on the angular speed of the pedal. Now he has introduced a chain.
Then decrease the
Why?
because the radius is decreased and speed is there.
But radius, and it's a ratio, na? The angle will also come in the same ratio. In my opinion, that it should be the same, because look, the effect of the change. Anyways, but theory question, you people can suggest, give me a suggestion.
सर एक चेंज में ना और दोनों
Hmm?
चेंज में एक चेंज